That's fine. Uh, so some people I know in the audience, basically. Okay, so I'll continue, and then we'll put recording for others. So this is brief history of CICD. Like, if you want a full history, then there are books like DevOps Handbook and Accelerate that will give you like many more details. But this is brief history how I see it, and sometimes the order maybe. I mean, a lot of things were happening at different times, so it's not very linear, I would say. But essentially, CI/CD starts with version control. So you have various version control system, which actually culminated in Git. Git is a distributed version control. You can also say that before there was a non-distributed with like Subversion, if some of you worked with the tool, uh, which then went to Git. So Git allows us to do version control and do it in a distributed fashion. So each person checking out Git repository is actually working with their own version of that repository. And they may get merged somewhere in the center, but they don't have to. Next thing that happened is a dedicated continuous integration system, which usually attributed, like Jenkins was big, it still is. Uh, what continuous integration system is, it actually is something that takes your source code, mashes it in, and produces artifacts. Um, Another way of putting it is it's a glorified script engine. So you have a bunch of scripts that you mash together, and you have an engine that lets you run those scripts. So you don't really have to do like scripts, a lot of scripts that are running the scripts. So that was a great advantage. Uh, Interestingly, a lot of people started using Jenkins to also run a CD part, so continuous delivery or continuous deployment, or in other words, use Jenkins to deploy software to the target instances, which is actually suboptimal, as we'll see later, but it's still better than nothing, and that also happened at that stage. So next thing that happened is a bunch of configuration management systems. And these are products like Chef, SaltStack, Puppet, and then Ansible. I put Ansible here because Ansible is the one that survived, and it's still in use right now, not even sometimes not even in legacy applications, but in real ones. So that's why I put Ansible here. Uh, so what those tools do, they actually take your infrastructure and keep it at some desired state. So you say, okay, I have my virtual machine or my bare bone, bare metal instance, and I want certain applications to work on this instance in a certain state. And these are the tools that allow to maintain and configure the state. Um, so that's like the second stage. So next comes actually I discovered that it's push based CD from CI. So that's what I just mentioned, overloading Jenkins, for example, or other CI engines to push code to like some infrastructure, or even create maybe infrastructure via some API, or like spawning virtual machines from Jenkins. So all this patterns would go into this category. Uh, and next, based on all those developments, came what was called IAC, or infrastructure as code, and sort of the headliner tool in there is Terraform. So Terraform provides its own scripting language to create infrastructure on different providers, and recently then it abstracted also a lot of like non-cloud provider tooling. So for example, you can actually deploy Helm charts and things like that from Terraform. The idea is you create scripts, you upload them somewhere to the version control, to say to Git repository, and then you have an engine that's running those scripts. And so the big difference is you don't have to click anything anywhere. You just write a lot of scripts. And this whole process was coined to be called infrastructure as code. Next, that's recent development that I wrote about is we kind of figured out that CI/CD shouldn't be actually mashed together. There should be separation of CI part and CD part. So in other words, you should be creating artifact only in CI part and maybe do some tests and some other uh, test like operations on this artifact. And then you should have a completely separate process to do deployment. And this also led to creating what's called a pull-based deployment systems. And one of the very big examples of that is Argo CD engine. So Argo listens to changes in the Git repository essentially, and then it runs manifests based on those changes in this Git repository. This allows for far greater scalability because uh, now in this pull-based CD mechanics, so every instance where you want to deploy stuff, you just put an agent on that. As before, what was happening, you had, for example, a central Jenkins server that would be pushing code to all the instances you may have. So if you have a lot, like let's say you have, I don't know, hundreds of instances, then push-based system is like, I mean, there are other considerations as well, but for hundreds of systems, push-based system is really a problem because you need to, for example, SSH to each of them and or do some other communication to them and like push code to each. While pull-based system, you can just configure a template that already has an agent inside, and it's calling some central, so some, for example, Git repository, and just pulling from that. So that this goes for far greater scalability. There are also some security and other considerations, but only this stage is really important. Also, your code is, I mean, the CI/CD code is goes much cleaner this way when you have separation of CI and CD phases. Next, all this actually comes to the coin term that's GitOps, which probably I've heard and it's like super popular right now. So what essentially GitOps is, and I have some other slide here, is using Git as a storage for the state of your infrastructure where you want it to be. Uh, and essentially, you only work with Git to configure your infrastructure, your CI, your CD patterns. And I'll describe it a little bit later, so I won't stop here. Just to remind you, like send me a message or like read me if you can follow the chat and interrupt me if there are questions or anything. So later I'll discuss what may be coming after GitOps or what may be evolution of it. So we'll talk about it later. So I also added this slide because if you're just starting to work with CI/CD, it may be kind of overwhelming, and I kind of try to break it into the things that uh, sometimes are used inside. Still, it may seem like a lot, but at least you kind of, I hope when we're dividing into smaller blocks, I hope it kind of looks easier than when we just say, oh, CI/CD. So first, version control systems like Git, what we discussed. Second is artifact storage. So you need a place where you store, so for example, like Docker registry, container registry, that would go this way. Then scripts. Scripts were always the beginning of CI/CD. Then very important triggers. So CI/CD usually happens when you do something, when some action is performed. For example, you commit code and this triggers CI build. So you have a trigger on commit to do the build. Or if somebody gives some approval, then some other process happens. So that would be another trigger. There is a whole project like Argo events in the Argo ecosystem that only deals with triggers pretty much and different permutations of those. Uh, then there are agents. So agents are things that run scripts. So in that sense, Argo instance would maybe an agent, especially in the distributed Argo patterns when you manage like different clusters one from another. Next, there is tests. So tests are important. Uh, Orchestrators. So Jenkins would be like CI orchestrator, for example. Gates, some tooling to manage approvals. And finally, telemetry is also important because you need some feedback how different stages go, how the deployments go, and things like that. So also, it's also important that not all those blocks need to be in every CI/CD system, and not all are used. But essentially, CI system is just organizations of those things. And maybe I missed some, but I think those are most important in any case.
So agents would be the runners, like CI runners.
Right, right. Agents would be CI runners, yes, or stuff that's deployed on the infrastructure itself, like the again, Argo may act as an agent. So, for example, you may have Argo server that's managing Argos on other clusters. There is a pattern to do that, and then this would be an agent as well. I mean, it may be not the best example, but essentially, if you put something on your VM that listens to events or let's say changes in the Git repository, which also Argo does, that's actually agent functionality. Because your storage or your hub, your center is elsewhere, but on the cluster you have agent that listens to it. Okay, I hope
Okay.
that
Okay.
makes sense.
Yeah.
Uh, Um, so another important development that we got to is the pattern that's called trunk-based development, which is the king. And I took this in the next slide from my other presentation that I did before on versioning. So essentially, trunk-based development, you see here, we have like the main branch, which is for some reason I can like fortunately doesn't let me use my mouse. I don't know why, but it's fine. So we you see main branch, which is second row from bottom, and this is where all the commits are going into, and all the deployments originate from this branch. So in the simplest case, we only have that main branch. Uh, and this is essentially single and most important point of truth. There are in some patterns we can still create feature branches, but they get then merged back to main, absolutely in any case. And we can also create release and maintenance branches. But what's important in this paradigm is if you create release branch, it does not then get merged back to main. So it's a temporary branch that will die eventually, but the last used code will always be in main. And also it's best if you still can do releases out of main directly, although it's not always possible because sometimes we need to do like hot fixes and security releases and stuff like that. So these are what those releases branches usually are, not for additional functionality, but for security and code fixes of some older deployments. So everybody goes to me. Um, so if you thought that was complex, that's like on the right, that's the Git flow. So I think it's clear just from those two diagrams that this one is way more complicated. The key problem with Git flow and why we don't recommend it today is merges. So the amount of merges is insane, and in version control, the most difficult part is merging code. And in DevOps code as well, like merges are the biggest evil. So you basically you want to set your development in such a way that you minimize the number of merges. If you manage to do that, if you don't have many merges, then you're golden. So the less merges you have, the better, the faster your development cycle would be. Like better lead times and everything. So trunk-based development is another. It's actually not a new thing. Like I know some organization did it like maybe 20 years ago. So people were doing it for a while, but these days that's really with microservices and containers and stuff. Trunk-based development is pretty much the only reasonable way to go. Um, okay, so now let's talk a little bit more about GitOps. Yeah, trunk-based development is actually also important in terms of GitOps because if you're doing GitOps, you kind of need to do TBD, because otherwise you'll be lost with Git flow pretty badly. So GitOps is cool because Git is actually it has a built-in state machine. So I don't know how well you know Git, but essentially every Git commit represents a complete state of repository. So it captures. So some people think that Git captures the changes between different states, but that's not accurate. What Git captures every commit is the full state. So there are implementation details how it's stored and optimizations and such. So we won't be touching those. But from the logical point of view, every Git commit represents a full state. And in that sense, Git gives you a full state machine based on commits, branches and such, where every commit is a full state. So it's kind of cool. You have a built-in state machine in there. So second, distributed storage. This is actually this true about Git. This is not true about every version control system. So like I mentioned before, if you saw Subversion, if you work with Subversion, that would not be a distributed, it would be a centralized storage, but Git is a distributed storage. And the cool part about that is you have to kind of have to worry less about backups and stuff. Because, for example, GitHub has a very poor reliability recently. Again, I don't know if you noticed, but it was down pretty much daily for the last week or something. And but because it kind of relies on Git, and because most of the people would have this Git code checked out as where, then most of these people they don't really freak out about losing everything that's on GitHub. So that's actually very important in terms of disaster recovery, reliability, and things like that. That gives peace of mind that okay, that you know that this same repository is probably checked out in many on many machines, and so it's not too bad that the central repository on GitHub is down. For I mean, it's bad, but it's not awful. Like the risk of losing everything is probably low by default. It has audit capabilities because you can actually trace the change history and stuff like that. And it also has built-in different capabilities. That's also important, so you can actually compare what changed between different commits. So those are the pros that I counted. There are probably more, but that's what I prepared. Now there are some problems with using GitOps. First, most important is what I call pull request mess. So I'll explain a little bit. So in the modern world, the key tool to work around GitOps is like doing pull requests. So people, so Git is lacking some, and actually that's my second point here. Git by itself is lacking some natural capability to do enterprise level logic. And in infrastructure in DevOps world, what you want is you actually need, for example, approvals or gates to move code from one level to another. So, for example, you have test, staging, and production environment. You deploy everything to test environment, and then you need, I don't know, QA approval for it to go to the next environment, which would be staging. So in GitOps world, I think up to now, although like other tooling appear slowly, and we also work on that, uh, the golden way to do it was to make a pull request. And then on this pull request, there would be some approval given by QA team. And if this approval is given, pull request is approved, then it gets merged to, say, main or to some other branch. And then after the merge, the thing gets deployed to staging. So that's usually how GitOps pattern is known to be operated. I personally don't think that it's optimal or efficient, but that's common. The problem with that, again, when you have many environments, this creates a lot of pull requests, which are hard to track. And if you remember what I said before, like merges are biggest of evil. And pull requests, they imply merging because so you approve pull request and it does the merge. So now you have merged everywhere. So everything is done via merging essentially. And this very quickly this becomes a problem. And also there is a human problem here when you have a lot of pull requests. People sometimes they forget about them, they don't approve and things don't happen, and which is also an issue. Like second point is comes out of this. Even if you think about pull requests, that this is not Git native functionality. So Git natively has pull requests, but when you work with say GitHub or GitLab or Bitbucket, all of them have their own, and they are not native to Git. They are native to these tools. So these things, although common, they're non-standard. And as they're non-standard, they're not highly portable, I would say, and also they may work a little differently between different systems. So this creates also additional layer of issues. Also, like security-wise, how do you set permissions? Who can do things? Who cannot? So all this becomes like tooling specific, and it's not. What I mean by lack of standards, so it's not even clear what those tools should do sometimes. Like what are exact requirements that we need on top of Git to make this thing work for enterprise? We kind of we have idea, I would say, but it's not standardized anywhere. Final thought is Git by itself is unfriendly for non-developers. Sometimes, actually, more frequently than before, we want business people, non-technical people, to participate in CICD and approvals. Like marketing people need to know about our deployments, things like that. When they work with GitOps, things are usually not clear to them. A lot of developers would brush this off and say, okay, it's not important, they don't need to care, but that's actually frequently not true. And if they would understand better what's happening, like what are exact changes that's going in, what are versioning patterns that's going in, it would make frequently life easier for many people, and it would remove a lot of friction between developers and business people. Okay, and this is what I wanted to say before, but this is like the nutshell of GitOps. So again, it's my interpretation, maybe opinionated, but essentially GitOps is just using Git as an underlying database for DevOps operations. And why is I mentioned about the pros of it is essentially you're getting built-in state machine in Git, and that's why a lot of people are using it. Um, so that's what it is. So as I mentioned before, as we're talking about okay, what's coming next. So first, I think most important that I mentioned a requirement for on top of GitOps is we need this standards for tooling on top of GitOps, like how we do approvals, how we and minimizing number of pull requests, and the same goes in the same venue. That's what a lot of people actually want. So how do we make it less sort of pull request dependent? And again, friendly for non-technical users and also for technical users as well. And that's actually what I put platforms. So platforms is emerging technology that's popular this day. So these are sometimes called internal development platforms or DevOps platforms. These are tools that abstract a lot of those Git and other operations and make them friendly for both developers, meaning non DevOps users, and also business users, which don't are not developers nor DevOps. So platforms are tools that abstract operations on top of GitOps pretty much, and possibly some other tooling. So that's emerging technology that's kind of going in. So one of the big open source platforms is Backstage, but it's very complicated. There are other tools, and we also work on one of them. Um, yeah, thank you. I think basically that is all I wanted to share today, and I wanted to make a short presentation. And now, hopefully, maybe we'll get some questions, or if not, we'll just conclude here. So let me stop sharing, and I'll get back to you. I just need to figure out how to stop sharing. Okay, then I can get back to the stream. And yes, everything is recorded, so you'll be able to see the recording. Uh, so if you have any questions or comments, I'd appreciate like you can so two ways either request permissions to go on stage and then you can speak or just type in chat. If you request permissions, I'll approve the request. So for certifications, I would say they are not that important, basically, especially at this point. So there was a point where it was really popular for like CNCF certifications, and I experimented. Yeah, as I mentioned, I got like a bunch of Kubernetes certifications at one point, but personally, at this point, I would say kind of. Uh, it maybe yeah, no, that's not actually true. Like, so most of the relationships, and so I'm doing like contracts, and yeah, I had some experience, but I got them before all this, before I got certified. And yeah, so there was a point that where, so let's put it another way. If you feel like recruiters are asking for certifications and you feel a little kind of down on that, then got a few of them. Like you can get CKA for sure. And if you need, I don't know, if you're specializing on AWS or something, got get maybe some AWS cert, and just forget about that. So that uh, there are frequently like 50% off or something discount codes. You can find them. So never, if full price is 600, like I saw maybe a week ago or something. So there should be 50% off codes at least. By the way, do you want to go on stage? Then we can speak it. It may be a bit easier this way. You find 50% off if you follow like CNCF and follow like forums and stuff. I'll try to find you links. I'll try to find you the discounts. But yeah, so 30% off is common. 50% off happens sometimes. Also, when I was getting them, it was much cheaper actually. I think the full price was certainly not 600. So probably they're not doing that well recently that they needed to raise the price. But it certainly wasn't. I think it was on the order of $200-300 or something. So yeah, 600 is a bit steep, I think. So I'll try to find some links for you. I'll send you after. Is it worthwhile to move from Sun to? So if event-based change is already automated, like I don't. Oh, okay, I see what you mean. But okay, I understand. So you mean on demand? So let's say you do commit and it triggers. Uh, I'm just reading the chat if anybody is confused about that, so you can see the message from Andres. I don't fully understand your last sentence again if you want to speak, but basically, if you look at, for example, Atlantis, then this would react, yeah, it would react near real time on your Terraform changes, and that's generally considered preferable than running it on a schedule. So in all cases, it's better for sure to run consistently rather than on schedule. So the only reason people may be running things on schedule is if you're afraid that you will break things, and it may mean that you don't have proper approvals in place. So you take, let's say, a week or something that okay, so if you do it once a week, most probable reason for that is you're not sure about your changes. So you know when the next schedule ticks. So before that schedule, you sit and review and kind of make sure that it's okay. And this is the only reason I see to run things like that, like Terraform or others on a schedule. Uh, so you need to build some sort of confidence to make sure that you can run it outside of schedule. Uh, and for that, what you most probably need, you need proper testing and gates, and you should sort of invest in that kind of staging system that would work without gates, and then you can move your production one if it works sufficiently well. So that's how I see it. But essentially, yes, you like ideally you want to move to near real-time experience. Also, question of drift is actually important because drift happens sort of naturally in any case. Um, like GitOps doesn't really prevent drift completely. So when I think about GitOps, I usually think about desired state of your infrastructure, and then on your Git, there is some tool, like it may be a Terraform runner, maybe Atlantis, maybe like Terraform Cloud, or in another paradigm, it may be Argo, that takes whatever you have in Git and tries to deploy it on the actual infrastructure. What may happen is it may fail. It may fail completely or it may fail slightly. So if you have a failure on deployment, that means at this point you have drift already because you have some one thing in your Git infrastructure, but because it failed to deploy, you have a drift. So from that perspective, just having Git as the central database is not enough, and that what I mentioned on the slide, you need some telemetry. So you need something to tell you if your Git ops application was successful or not. So that, I mean, it's not like you have a lot of tools. So again, we're trying to do that for some parts, but it's not like you have a lot of tools that actually do that. But that's important thing to keep in mind that like Git is actually your desired state, not your final or finite state. Like not all the time your real state of what you have. It's like what you want to get. This is what you have in Git. So that's important. Playgrounds. So I recently wrote bunch of tutorials, but they are mostly about our tool plus GitHub Actions. So I can share those with you, and hopefully they'll be helpful. Again, I'll try to message you. Actually, I'll message you right now. So this is my kind of and uh, my recent tutorials, and there are two on top of that. They include our tool though, which we're building, but they also have GitHub Actions, and if you go through that, you'll get a lot of background information. Hopefully, just yeah, basically read my blog and last 3 4 posts. There, pretty much all of them are tutorials. And for Playground, like GitHub Actions, they have, even though they are not very reliable, as I mentioned, but they have like free plans and stuff like that. So you can use, so essentially all that's in those tutorials you can do for free so far. Andres, if you still have questions, let me know. We can discuss after. How do we cope with needing to spend creating labs environments just for learning purposes? Like Kafka. I would say Kafka is a little bit specific. Like for DevOps stuff, I wouldn't focus on Kafka at all personally. Um, Multiple nodes and ETL complex data integration. Yeah, so I would say so. Here are the options. So first, I'd say get a good. I mean, I don't know your budget, but I would recommend a good laptop. Yeah, go ahead. You can go on stage. Yeah.
So, so I'm agile potato, Taludor. You say like for DevOps, do not focus on Kafka. Let me show you something. This is database with all around 100,000 jobs. I'm gonna search for DevOps and Kafka, right? So I get 787 hits. If I just search for DevOps, I get 11,000, right? So let's do what is that? 787
So it's less
divided
than
by
10%. It's like 6%.
yeah 6%, right? Almost 7%. I don't know,
I
like
was faster than that.
yeah,
Okay,
you were.
so
So, but that's a considerable amount. I mean, it's not negligible. It's not like 0 point. You know.
no,
So
it's not negligible, but you need to consider the effort also. Like the effort that you put into Kafka specifically for like 6%. There are no, I mean Kafka is good, but my perspective so far, I mean, it didn't change from couple last years, but so far is the most important skills for DevOps still are Kubernetes and Terraform. So if you think you're so those two things, if you're doing great, then look at other things, and you still have problems. Yeah, Kubernetes, Terraform, and then one of major clouds. So either AWS or Azure, in that order, by the way. So Kubernetes first, then Terraform, and then
does this does this look okay? It's a Boolean search, right? So
yeah,
does it look to you?
yeah.
Okay, let's try. So so 32%, right?
Yeah,
So it managed to hit 32% of DevOps
yeah,
jobs.
and this was interaction, or this was or either Kubernetes or Terraform. I didn't capture that.
It's exactly what it says. Like this is or, right?
This is
So
or okay. I see. Yeah. So
this is that.
32%. Yeah, and these are I can tell you these are sort of higher quality jobs because so my expectations that Kubernetes would reach near 100%. So I see basically even in discussions a lot of kind of bullshit about Kubernetes recently. Let's put it like this, because so for example, a lot of people are telling now that okay, start with I know Lambda functions because they're cheaper even for smaller projects, because for Lambda functions, it can be. So we want, for example, to cap our costs for small projects to, I don't know, 40, $50 a month. And that's why we take like serverless. But the thing is, you can run a Kubernetes server on Hetzner. I don't know if you heard about the platform.
Yeah, yeah, I did. It's
Yeah, you can run a K3S server on Hetzner for $40 more or less per month, and you can have like a full going cluster and everything, and it would be same cost and frequently more performant than what you
uh,
get with
But,
lambdas and such.
but if
and
someone does not have know-how of DevOps, it's easier like go to market for them. So going serverless.
uh, I think we'll change so part of what, for example, we're working on is a little bit, and I know the other projects that do that is think like app store for Kubernetes, where you can actually deploy things on Kubernetes with just button clicks and stuff like that. So I think this part will change at some point.
can I ask? So Hetzner offers Kubernetes just like EKS, AKS, and
No, you get a VM. No, you get a VM, and then you just install K3S on this VM, and you're good.
Is that like a single node or?
Right, right. It's so think about one thing about the single node is single node is not terrible for small projects. So for single nodes, they have so basically if you think about single node, they have like a reliability pattern that it goes down once in so single node fails once in 1,000 days basically. So that's once in 3 years.
Yeah, I completely agree with you. It's just the case that when you're learning, like you want an environment which is as close as possible to what you would get on an actual job with a real infrastructure with multiple nodes and so on.
Yeah, so two things I want to mention. For AWS, you can use local stack. That helps a lot. I don't know if you're familiar with the project. It gives you like all AWS APIs locally, and without with which you can run on your laptop. So you kind of interact with AWS APIs similarly. So second thing I recommend is get a really good laptop. So invest in your laptop. Get like a gaming laptop with a lot of memory, and then you can run Vagrant clusters on that and do a lot of experiments on Kubernetes like on a single laptop. So those are two things I can recommend here.
And
Uh,
I mean, yeah, so we switched from cost to cloud to cost for hardware on-prem. Um,
that's your development machine though, so that it's not like on-prem. It's you're talking about your lab, so that's basically what I can recommend there. What worked essentially for me and other people. But
yeah, it's great.
but of course you won't you can't get a lab with I don't know, even with 10 nodes or like it would be too expensive frequently. um, but I can tell you for like to land a job with Kubernetes, to figure out like get CKA certified and get a lot of those patterns going, that's actually more than enough. Like in most in many organizations, especially when they're like just migrating to Kubernetes and stuff, you don't really need those huge, like big, really big clusters. That's not where you start basically, and not where they start.
And is there an equivalent of local stack for the other major cloud providers like Azure or GCP?
I'm not sure, but for Azure, if you just register, they provide a lot of free learning. A lot of courses for Azure specifically is free. For GCP, I would say kind of ignore it. Like GCP is small, some startups are using it, but it's not that important. Like the share of
Um,
GCP is minuscule.
yeah, I can actually quantify that and tell you how much it is
Yeah, that's cool.
exactly.
That's cool. Yeah, your tool is cool. Okay, I'll read another question. When scaling up, you hit Lambda. That's what I was mentioning. That Lambda is actually not great frequently. Hetzner. Yeah, Oracle free tier is fine. Yeah, Agile Potato, like somebody is asking you, like Andres is asking you to share the tool if you can, but I don't know. You can talk with him directly after, if you can or not, or if you can share it with the community, that would be awesome. But I don't know if you can. So for Oracle, so question about Oracle. So Oracle has really poor reputation generally as a company and in terms of reliability as well. Oracle free tier is fine though because it's free. Just don't use it for production. The only thing it free tier on Oracle comes with, as far as I remember, on ARM CPU, not on Intel CPU. And on ARM CPU, a lot of things won't really work the same way. So because you need different architecture for all Docker images, and it's only partly supported. AMD CPU is fine because it has Intel architecture, but maybe it's new. I remember before it was only ARM, or maybe a limited capacity. You mean? Yeah, but I remember large nodes you could only get with ARMs. So Andres, look at the repository. Hopefully that helps. But yeah, I mean, any free resources are fine. So and ARM is fun to practice, but you don't really need it in
Yeah.
many. Sure. Yeah. Well, last question, and we'll wrap up because we're
Uh,
kind of out of time. Okay, go
yeah,
ahead.
yeah, that's fine. I was just thinking. I was thinking, so you said there's many Azure free courses. Do they end with the certifications, like with a proof of completion? And the more general question is like, how do we navigate uh, this entire uh, jungle of courses and offerings from different providers?
So this is my personal opinion, but as I mentioned before, I think at this point most certifications are really not important. Like most, I mean, maybe 95%. So there was a point of time when it was kind of cool, and yeah, everybody sort of tried, but this has passed, in my opinion. Uh, I would say CKA is kind of nice because even if it's easy, you need to do something. So if you were to pick one from Kubernetes world, I'd say pick CKA. And then specifically, yeah. So what you asked about Azure, uh, you need to pay for exams, but I saw some promotions. I don't know if they're going now or not, where Microsoft were doing it for free also. So you may be lucky and get it for free, but usually you get some learning and you get labs, but then you pay for exams. That's usually how it works. And about navigation, again, if you mentioned that recruiters are asking about that, what I would do is, yeah, like bite the bullet and get, I don't know, AWS DevOps or Azure DevOps, whatever it's called, like one of each, but like don't go into where I don't know 16x AWS certified. Like nobody cares. With the rare exceptions of people who don't know what they're looking for, like they're really onto certifications, but in many cases people don't care. That again, that's my perspective. You may have different experience or anything, but if you really feel that you're stuck because of lag, yeah, then get one and don't get more. Hope that helps. Um, okay, I'll just let you. I see there are some messages go. I'll let the last message go. Yes, CKAD. No, just CKA. I would say only take CKA. CKAD. I'd say is less important. Yeah. Uh, in my experience, people who care about search actually care about AWS more. That's what I saw. It may be again because you have your tool. Just check. So if you hit a wall because of this, maybe even take AWS first, even though it's less value to me. But it's maybe important to recruiters. I don't know to check the mark. Uh, okay, so I'll conclude. I'll let you type, but I'll conclude. So thanks everyone for joining. Hope that was helpful to somewhat extent. And yeah, I'll do recording. I hope it worked this time because last time I had some problems with recording, and then I'll put the recording of my presentation. So now I'd like to make those meetings kind of more or less regularly, so I see actually, which is good. There are a lot of questions about certifications, tooling, how you can make a home lab and stuff. So maybe we'll make it a topic of some next event. But think about more. Also think about whether if you want to present something, that would be very much appreciated. So not I present, but one of you presents. That would be really cool. So think about all those things. Let me know. And tentatively, I want to make it monthly event for now, and then we'll see about frequency. If we have enough contact, enough interest, and then we'll go. But yeah, I think actually home labs could be a different and an interesting topic for the next one. So far from the questions, or if you have other questions, then let me know. So thanks everyone for joining. We're still all here on Discord, so feel free to message. And Agile Potato, thanks for the tool.